This is lesson 6.2, solve systems by substitution. So in lesson 6.1, we learned how to solve systems of equations by graphing, by laying those two equations on a coordinate plane and determining and interpreting the graph. If the two lines met at one point, then that point was the solution. If the two lines were parallel, we learned that there's no solution because those two lines don't share a point. And if those two lines happen to really be the same exact line, both equations share every point, then we interpreted that graph to mean that the system has infinitely many solutions. In this lesson, lesson 6.2, we're going to use a different method to solve systems of equations. We're going to use the substitution method. Okay, substitution is an algebraic method of solving systems of equations. No graphing is involved here. We're going to use algebra to solve the system. All right, so jot down these notes. This is the process you will use to solve by substitution. Number 1, isolate one variable on one equation of the system. So make sure that one of the equations of your system has one of its variables isolated. Number 2, substitute the resulting expression for the given variable in the second equation or in the other equation. Number 3, solve for the first coordinate. Number 4, substitute the solution in the original equation and solve for the second coordinate. Okay, so notice substitute, substitute. That's why this method is called substitution. All right, let's start with example number 1. Here's your system of equations. Okay, so step number 1, make sure that one of your equations at least has one of the variables, either x or y, isolated. And in this case, you know what? The first equation has y equals 2x plus 1. It already has y isolated on one side. Okay, so here's what we're going to do. We're going to take this expression, which y equals, and we're going to substitute it for y in the second equation. So that's our second step. We're going to substitute. So let's write that down. We're going to work with this equation, substituting this expression, 2x plus 1, we're substituting it for y. Okay? All right, so let's do that. 3x plus y, which is 2x plus 1, is equal to negative 9. Okay, let's solve for x now. Combine the like terms. 5x plus 1 is equal to negative 9. Let's subtract 1 on both sides. 5x is equal to negative 10. Let's divide by 5 so that x is equal to negative 2. So remember, we're looking for either a point, no solution, or infinitely many solutions. It looks like in this case we have an x. So that is going to be the x coordinate in our solution. Remember that our solution will be an ordered pair. All right, now that I know that x equals 2, what I do is I take the 2 and I'm going to substitute it back into my original equation. Whoops, sorry about that. Let me do that again. Back into my original equation for x, and then I'm going to solve for y. So let's do that. Y equals 2 times x, which is negative 2, plus 1. 2 times negative 2 is negative 4 plus 1, y equals, and so y equals negative 3. So there is my y, negative 3. So that is my solution. If I want to check my solution, what I would do, and I'm going to go ahead and check this one, and I'll do it in red just to show you how to check. What you would do is you would substitute your solution into both equations and make sure that they make both equations true. So let's start with the first equation. Y, which is negative 3, is equal to 2 times x, which is negative 2, plus 1. Negative 3 is equal to negative 4 plus 1. Negative 3 is equal to negative 3. So that one checks out. Let's now check the second one. 3 times x, which is negative 2, plus negative 3 is supposed to equal negative 9. Well, let's see. 3 times negative 2 is negative 6, plus negative 3 equals negative 9. Negative 6 plus negative 3 is negative 9 equals negative 9, and it checks out. So you can always check to make sure that your solution is correct. Okay. Okay, here we go, number 2. Please write down your system. Here it is. Your system of equations, remember, is 2 equations that you're solving simultaneously. Okay, remember that our first step is to look at our 2 equations and make sure that one of the variables is isolated on one of the equations. And in this case, we have y equals. We have y equals. So we know that y equals this expression. We can use substitution. We can take that expression and substitute it for y right there. Okay? So that's where we're going to start. So 2x plus 5 times this expression, 3x plus 10, is equal to negative 1. Alright, so now we're going to solve for x. So 2x plus 15x plus 50 is equal to negative 1. Let's go ahead and combine like terms. 17x plus 50 is equal to negative 1. Subtract 50 on both sides. So 17x is equal to negative 51. Divide both sides by 17 and you'll see that x is equal to negative 3. So x is equal to negative 3 is half of my solution. I have part of my ordered pair. Okay, so I'm going to write down x is negative 3. Remember, it's x comma y. Okay? Alright, so let's go ahead and do the substitution one more time. This time, I'm going to take the x and I'm going to substitute right there. Okay? Alright, so let's do that. Y is equal to 3 times x, which is negative 3, plus 10. Y equals negative 9 plus 10. Y equals 1. So my solution is negative 3 comma 1. X is negative 3, y is positive 1. And again, if I wanted to check the accuracy of my solution, all I need to do is substitute negative 3, 1 into both original equations. So let's do that. 2x, 2 times negative 3, plus 5y, 5 times 1, is equal to -1. Let's see if that's true. 2 times -3 is -6, plus 5 times 1 is 5, is equal to -1. That one checks out fine. Now let's try the second equation. Y, which is 1, is equal to 3 times -3 plus 10. 1 equals 3 times -3 is -9 plus 10. 1 equals 1, and that one checks. So it's really important for you to know that you can always go back and check the ordered pair to make sure that it is the correct solution to this system. Okay? All right, let's look at number 3. Number 3. Here's my system of equations. 4x minus 5y is equal to 11. 4x minus 5y is equal to 11. And y minus 3x is equal to -13. First step is to make sure that y is isolated or x is isolated on one of your two equations. You need to have a variable that is isolated. And if you look at these, there is no isolated variable. If you look, x and y are together on the same side on both of these equations. So what we need to do is we need to algebraically rewrite one of them so that y or x is isolated. And the easiest thing to do is always look for the variable that doesn't have a coefficient and decide to isolate that one. So I am going to choose to isolate y on the second equation. Okay? So I'll go ahead and do that off to the side, okay? So y minus 3x equals -13. That's the original. I'm going to add 3x on both sides. Y equals 3x minus 13. Okay? So now that I've rewritten this second equation, okay, I can use it to substitute. Okay, so y equals 3x minus 13. That is what I'm going to use right here to substitute into my other equation for y. Okay, so let's start there. 4x plus 5 times y, which is 3x minus 13, is equal to 11. Let's solve. First I have to distribute 4x plus 15x minus 65 is equal to 11. Let's combine these like terms. So I have 19x minus 65 is equal to 11. Let's add 65 on both sides. And I have 19x is equal to 76. And we will go ahead and divide both sides by 19, and x equals 4. Well, now that I've solved for x, I need to take this and put it back into the other equation, and I'll do that right here. All right, so let's do that one. Y equals 3 times 4 minus 13. Y is equal to 12 minus 13, which means y is -1. Okay, so let's write our solution. X is 4 and y is -1. Okay, I'm going to check that. Why don't you pause the video now as we check this so that we can come back and make sure that we did it the same way. So pause the video and check the solution. Okay, the solution for -1 checked out just fine for both original equations. Okay. All right, here we go. Number 4 on your own. Go ahead and solve for number 4. Pause the video now. Okay, so when I attempt to solve for x on this equation, notice that right here, after I distribute the 3, I combine -6x and 6x, and I get 0x, and I lose my variable. I'm left with a statement. -12 equals -12. Whenever I lose my variable on an equation and I'm left with a statement, I need to analyze that statement and ask myself, is it true? If it's true, then it's all real numbers or infinitely many solutions in this case, since this is a system of equations. If it's not true, then it would be no solution. In this case, -12 is equal to -12. Therefore, we have infinitely many solutions. Okay, try number 5 on your own. Pause the video. Okay, notice on this one, I also lose the variable. I lose the variable when I distribute the -1, the negative sign that's there. I get 2x minus 2x is 0x, the variable is gone. And I'm left with an equation that says 3 is equal to 8. Well, is that true? No, 3 is not equal to 8. Therefore, there is no solution to this system. And if you were thinking about what this looks like when you graph them, you know that you have parallel lines. Because there's no solution means that they're never going to touch. They don't have any points in common. Okay. All right, for some independent practice. 3, 5, 7, and 9. You're using substitution to solve these systems. And that's it. We'll work on the word problems in class. Okay? All right, so get to work on the independent practice. We will check it tomorrow. We will go over these. All right, God bless you. Have a great night.